A parallel plate capacitor is charged by a battery to a potential difference V. It is disconnected from the battery and then connected to another uncharged capacitor of the same capacitance. Calculate the ratio of the energy stored in the combination to the initial energy of the single capacitor. So in this question, we have a parallel plate capacitor. Let us say the capacitance is C, which is connected to a potential difference of V volt. So initially we have connected across a battery of potential difference V volt. So once you connect it to a V volt, the initial potential will become V and the charge stored will become Q. After this, we are disconnecting this capacitor from the battery and we are connecting this capacitor across another uncharged capacitor of the same capacitance. So when you connect, the first capacitor is fully charged. When you connect another capacitor across it, we can see that the charges will flow from the first capacitor to the second capacitor until their potentials will become same. So in this case, we can say that after a particular time, we can see the potential of both the capacitors will be the same. So we will be same after some time. So we can write down the potential due to the first. Let us mark the charge on the first capacitor as Q1 and charge on the second capacitor as Q2. And we have already mentioned that the potential will be same after some time. So we can write down the potential across the first capacitor as V1 and the potential across the second capacitor as V2. So we can say V1 is equal to V2 and V1 will be nothing but Q1 by C and V2 will be Q2 by C. So from this we can see that capacitance is same. So we can cancel C, we can say Q1 is equal to Q2. Since Q1 is equal to Q2, the initial charge is Q. So Q1 and Q2 will be same. So Q1 will be Q by 2 and Q2 will be capital Q by 2. So this is a charge on each capacitor. So we got the charge value. So we can write down the potential from this relation. So potential will be nothing but V is equal to Q by C. So Q1 by C. Q is nothing but Q by 2. So Q by 2C you will get and V2 will also be the same value. Once we get the value of V1 and V2, we can calculate the total energy. So your final will be equal to half into CV square. That is C V1 square plus half into C V2 square. V1 and V2 are the same value only. So we can write down 1 by 2 plus 1 by 2 will become 1. So C V1 and V2 will be Q by 2C whole square. So we can write it as Q by 2C whole square. So this is nothing but Q square divided by 4C. So this is your final energy. And initial energy we can calculate as U initial will be equal to Q square by 2C. So initial is Q square by 2C and final is Q square divided by 4C. So the ratio of initial to the final will be 1:2. So this is the answer for this question.